event, maybe even more. So it was a very strong event. As far as the trail, you kind of work that out. The meteor was about 30 seconds. It was moving approximately 10 miles per second, so it left a trail about 300 miles long.
Great. Thank you so much.
Next question comes from Irene Klontz with Reuters.
Hi. Thanks very much for doing this. I was wondering, when you said that this the asteroid or the meteor that came through over Russia this morning couldn't have been found because of the coming in from the daylight side, what about if there was any observatories or anything that could sense the infrared? Would it have been too small to be picked up on that? And getting back to an earlier question about in the United States, of course, we think we can control anything, and if Congress says, well, what can we do about this, what would you say?
Paul is the expert on telescopic observations of these, so I'll let him deal with the infrared question, certainly.
Could you repeat that first question? I'm sorry. I thought Bill would take that one.
Yeah, I wanted to know if there was any other way of detecting the meteor aside from the visible light, which you said couldn't be seen because it was coming from the sun, and then just in a more general sense of if there is some action taken to try and prevent these sorts of things, or at least give some advance notice that they're happening. Is there anything that can be done, or is this just part of what it means to live on planet Earth?
This object could, let me see if I get this right. This object, hang on a second. Yeah, I'm sorry about that. The infrared does not work from the surface of the Earth. We wouldn't be able to detect that. Asteroids need to be found against the dark sky. So infrared observations from the surface of the Earth won't serve to detect asteroids like this. They're generally detected optically. They're not detected with radar. They're too far away generally with radar. IR detection, infrared detections from space, that is an option that is being looked at as a possible way of detecting these objects. That we would require a spacecraft, of course, to orbit near the Earth or elsewhere to search for these objects.
To answer the second part of your question, I can't really speak to Congress, but I can tell you that NASA has recognized that asteroids and meteoroids and orbital debris pose a bigger problem than, anybody anticipated decades ago. And I can say certainly my office, and I believe the near-Earth object that Paul works in, our resources have been increased over the past year or two. So certainly NASA has put forward more resources this year into both our offices to try to help improve our capabilities here.
Thanks very much.
Next question comes from Peter Spatz with the Christian Science Monitor.
Well, thank you very much for doing this. I guess maybe this is for Paul. I wonder if you could just sort of briefly sketch out how you work backwards from the observation of the event that we saw today on all the videos to this estimate of size and mass. And do we have any sense at all as to the composition of this? I presume it's because it was an airburst. It's probably a rocky asteroid of some sort. But can one say anything more about it at this point?
Let me answer the second question first. The fact that it broke up gives us some information on the composition. It was probably not an iron-nickel type of very dense asteroid, such as the asteroid, the Shikote-Alin asteroid that hit in 1947, also over the Soviet Union, which was a metallic object. And could you repeat the first question, please?
Oh yeah, just kind of briefly sketch how you work back from whatever observations you use to derive a mass and a size estimate for this.
The principal source of the information is on the energy released, which is determined by infrasound detectors on the ground. They are an excellent source of measuring the pressure waves that are created by the detonation in the atmosphere. So that will give a rough idea of the size of the energy, of the amount of energy that was released. So the initial and preliminary information is coming through the infrasound network.
Thank you.
Next question comes from Bill Harwood with the CBS News.
Yeah, thanks. And Paul, he just answered my question, but I'll follow it up and ask you to explain what this infrasound network is. I'm not familiar with that. Thanks.
Bill, can you take that one?
Sure. The infrasound network was established to monitor for nuclear explosions. You know, there are nuclear test ban treaties forbidding surface nuclear tests. So international agencies established a network of infrasound stations all over the globe designed to detect big explosions in the atmosphere. And when you have a significant event like this, these infrasound stations will pick it up because, as you can guess from the energy of 300 kilotons, this is similar to a nuclear explosion in magnitude. So we're basically leveraging the network designed to detect nuclear explosions on the surface of the Earth to give us information about a meteor exploding in the atmosphere.
Thank you very much.
Next question comes from Naomi Seck with AFP.
Hi, thanks. My questions have mostly been answered, but I'm just curious, can you sort of sketch the trajectory? So it was in the asteroid belt. How long ago would it have left, and can we reconstruct the path that this tiny asteroid took?
Bill, can you answer that one?
Yeah, hang on one second. The asteroid, the Meteor, or the small asteroid over Russia, the preliminary orbit indicates it takes about 1 years to go around the sun once. So it takes about a couple of years to go around the sun. So this thing was out at its farthest distance from the sun roughly a year ago. So it was out in the main belt roughly a year ago.
And of course, let me add to that, of course, it would be in an orbit which would cross the Earth's orbit. That's why it could hit the Earth. So it was an orbit that extended. We don't know how far it went inside the Earth's orbit, but at its farthest distance from the sun, it would be in the asteroid belt. The asteroid belt is the source of near-Earth objects. They are the leftover bits from the formation of the solar system. They would have formed a planet if there weren't other gravities, large planets nearby, such as Jupiter, which prevented the formation of a planet at that distance. So the material is left there in the asteroid belt. And gravitational effects can channel asteroids to come into the inner solar system and cross the Earth's orbit. So that's the mechanism by which asteroids from the belt migrate into the inner solar system and can become a hazard to the Earth.
Next question comes from Leo Enright with Irish TV.
Thanks very much for doing this. I have a couple of questions, if I may, about the shock wave. You mentioned this infrasound network. I'm wondering, is this a shock that was heard around the world? Was this being picked up by infrasound networks at great distances? And my second question is more local as to the whole sequence that created these shock waves. Watching one of the videos, I was pretty certain I heard 5, maybe 6 distinct explosions. And I'm wondering, can that be explained by the dynamics of this thing? I've heard things about pancaking and then things breaking up. I mean, could you talk a little bit about what actually might have been happening that may have created 5 or 6 distinct explosions?
Yeah, this is Bill. As far as to the number of infrasound stations, right now our energy estimate is based on 4 infrasound stations, though it was certainly detected on more. As to whether or not this was heard all the way around the world, they haven't polled all the infrasound stations, so at that time I'm unable to answer that question. So our energy estimate is based on data from 4 infrasound stations closest to the event, and it was certainly seen on or registered on other infrasound stations, but whether or not it was seen on all infrasound stations, we don't know at this time. It's still early on. And I can let Paul address the shock wave stuff.
I believe that the atmosphere protects us and will disrupt the asteroid as it's coming in. So there will be fragmentation events. And as the asteroid disrupts, and it effectively divides into multiple meteors, and so that is one possible source of multiple shock waves. And there are other dynamical reasons why we might get multiple shock waves as well.
Next question comes from Bill Denniston with 21st Century Science and Technology.
Hi. Yeah, I was wondering if there's a discussion about how to seriously defend the Earth from these smaller asteroid bodies. Because I know from the last I heard that the Congress has asked NASA to find bodies down to 140 meters across, but there hasn't really been an explicit goal to find these bodies down to obviously this range of 15 or the one that's flying by today, 2012 DA14. I was also wondering, explicitly in the context of the Russian Deputy Prime Minister, Dmitry Rogozin, responded to this event, this meteorite explosion in Russia, saying that the U.S. and Russia should cooperate to develop the capabilities to actually stop even small bodies like this from impacting the Earth. So I was wondering what the status is to actually address the challenge of stopping impacts like this from happening.
Defending the Earth against tiny asteroids such as the one that passed over Siberia and impacted there is a challenging issue. That is something that is not currently our goal. NASA's goals are to find the larger asteroids. Even DA14 is on the small side, and it will be difficult to find the majority of those. So many of them could go undetected for a significant length of time. The tiny asteroid that hit over Russia this morning, actually it was over the Ural Mountains in Russia, is very difficult to detect all of those and therefore defend the Earth. And in order to, quote, defend the Earth, the problem there and the issue would be to find these things early enough so that something could be done about it. And the warning time, in other words, would have to be a considerable length of time if we wanted to divert such an asteroid or some scenario like that. So even though the smaller ones are easier to divert, they are very difficult to detect. I'm sorry, I was going to add that, yes, we are focusing on the larger asteroids first. They are the ones which are the most hazardous. The object that entered over Siberia this morning was of a moderate explosion, and frankly was nowhere near the devastation that you would get from a larger asteroid hitting the Earth. Those are the serious ones that we need to focus on first.
Next question comes from Roxanne Palmer with International Business Times.
Hi, thank you. I'm curious, we seem to hear about a lot of significant meteor impacts in Russia and I guess the former USSR. Is this just a coincidence that all these events seem to happen there, or is that like a function of Russia being a very large land mass?
I think you have it hit the nail on the head there. Russia is a large land mass, and it is